we've been talking a lot about theory, z-scores, and the area to the right and left of z-scores, the area between two z-scores. But now what we're going to do is start to use raw scores instead of z-scores. We know how to find the area between z-scores under the normal bell curve using NormalCDF. Okay, so we can look at this picture and recognize that the lower z-score is negative 100,000 for negative infinity. The upper z-score is negative 0.53. The mean is 0. The standard deviation is 1. And we could find out the area that's shaded in here. The lower, when it says lower on the calculator, we're referring to z on the left, which for us in this picture would be negative 100,000. The upper on the calculator represents the z-score on the right, which is negative 0.53, and we've been always entering a mean of 0 and a standard deviation of 1. So we know how to find the z-score that corresponds to the area to the left of a location under the normal bell curve with IMV norm. So here's an example of a picture that shows us the bottom 20% of area. So we simply use IMV norm, plugging in an area of 0.20. It will always be expressed as a decimal proportion of area to the left, never as a percent. And we've been letting mu be 0 and sigma be 1 for all these examples. Okay, now we're going to look at how the properties of the normal distribution can be applied to real-world situations. So we're going to look at problems that instead of providing z-scores to us, they give us raw scores. Okay, when we use raw scores instead of z-scores, the use of NormalCDF changes just a little bit. Our lower value on our calculator is going to represent the lower raw score instead of a lower z-score. The upper value on the calculator will represent an upper raw score instead of an upper z-score. Mu is going to be the real world mean, and that has to be provided to us in a problem. And sigma will represent the real world standard deviation, which will also be presented to us in the problem. So let's look at an example where we're looking at a distribution of tire wear, and we're told that it's approximately normal. So if it's approximately normal, it means we could estimate probabilities and proportions based on the bell curve. We're told that the mean is 48,000. And I'm going to tell you right now what this means. This is in miles. 48,000 miles is the mean. The standard deviation is 2,000 miles. Find the proportion of tires which would be expected to wear less than 46,000 miles, more than or greater than 49,000 miles, between 47,000 miles and 51,000 miles. Okay, for each of these parts of the problem, the mean is always 48,000, the standard deviation is 2,000, so that never changes. To find the proportion of tires that are less than 46,000 miles, essentially we are being asked for the proportion of area under the bell curve less than 46,000 miles. So let's make a bell curve. If we're told that the proportion that tire wear is approximately normal, it means that we have a normal bell curve. So we start by making a normal bell curve, and in the center of that normal bell curve we can label the mean at 48,000, which is this location right here in the very center, and the standard deviation is 2,000. Now 48,000 is labeled on the horizontal axis right in the center. So in part A, when we are being asked for the proportion of tires less than 46,000 miles, well, you have to note that if 48,000 is right in the center, 46,000 is somewhere on the left side of that. So we make a picture where that represents 46,000 somewhere to the left of 48,000. and we draw a vertical line, and we shade in the area that's less than 46,000. Now we shade in the area less than 46,000 is all that area to the left of 46,000. Okay, remember that the horizontal axis is labeled from low to high, so less than 46,000 is everything on the left side of 46,000. So we're being asked to find the proportion of tires with miles less than 46,000, which essentially is this proportion of area under the bell curve. So we can use our normal CDF function on our calculator to find that proportion of area. So we go to our calculator, and the four things that should be put into a normal CDF is the lower raw score for the lower value. Now, since this area is shaded all the way to the left towards negative infinity, we're going to use a negative infinity of negative 100,000 to represent that lower score on the left. On the right, the upper is going to represent the upper raw score. That's going to be 46,000. The mean is 48,000, and the standard deviation is 2,000. So those pieces of information, 48,000 and 2,000, need to be provided to you before beginning the problem. So now you're going to go to your calculator, and you're going to enter those four values. So second, DISTR. Normal CDF, because we're trying to find a proportion of tires. Since we're being asked for a proportion of tires, essentially it represents area under the bell curve. Now that area is found with normal CDF. Our lower limit, negative 1e99, is the calculator's way of representing negative infinity. I'm going to use what we've been using in the past, negative 100,000. So from a value on the left of a negative 100,000 all the way to a value on the right of 46,000. I put too many zeros. There we go. A mean of 48,000. A standard deviation of 2,000. And we go down to paste. We hit enter. And the proportion of area is 0.1587. We're going to round these proportions to 4 places. So since the 5th place is a 5, we're going to round the 6 up to a 7. So it's 0.1587. So if we had to express verbally what it is we just found, we found that the proportion of tires that have miles less than 46,000 is 0.1587, or 15.87% of all tires. Okay, part B, greater than 49,000 miles. We're trying to find the proportion of tires whose miles are greater than 49,000. So we go to a picture again. Here's our empty picture that it serves as a model for each of the parts of this problem. Our mean is 48,000 still. Our standard deviation is 2,000. And the shaded area in this problem is going to be area to the right of 49,000. So if 48,000 is in the center, recognize that 49,000 is to the right of that. And the proportion of area greater than 49,000 is the shaded area on the right side of 49,000 all the way up to positive infinity. Greater than 49,000 means from 49,000 to positive infinity. Okay, so the things that we have to enter into our calculator now, see, set normal, second DISTR, normal CDF. Okay, the lower value now is 49,000. because this is the value on the right, the value on the left. And the upper, which is the value on the right, is 100,000. Positive infinity. So it always is smaller value for the lower, larger value for the upper. That's the way it will always be, no matter what kind of question we're doing. The mean stays at 48,000. The standard deviation is 2,000, and we paste it. 0.3085. Okay. 0.3085, which means that 30.85% of tires last more than 49,000 miles. Okay, 0.3085% of tires last more than 49,000 miles. The last part is to find the proportion of tires between 47,000 miles and 51,000 miles. This is basically the proportion of area between those two raw scores. So we make our bell curve again. 48,000 is in the center, so 47,000 is on the left side of that, and 51,000 is on the right side of that. The area in question is the area between those two numbers. This is the proportion of tires who have miles between 47,000 and 51,000. Okay, so we're going to go to our calculator. 47,000 is the lower, and 51,000 is the upper. 47,000 and 51,000. Our mean stays at 48,000. Our standard deviation is still 2,000, and then we paste it. 0.6247. 0.6247, because the 5 in the fifth place makes us round the 6 up to a 7. So 0.6247. Okay, so 62.47% of tires have miles that last between 47,000 miles and 51,000 miles.